Hello, everyone, and for the second set of lectures for week 3, we'll be entering the data wrangling portion of the course. So, the first thing we're going to talk about is reading and writing files. So, we'll be working with this I/O notebook for input-output. Before we can do much with data, we first need to understand how to bring data into Python and export it from Python. Thus far, all of the data we've worked with has been created within Python. We create variables or data structures where we simply either type in directly or programmatically generate data. And today we're going to talk about how to read data from files, which is the main way that we consume data in the modern computing world. You could never hope to write out a significant data set by hand into the Python interpreter. You would download a file from somewhere and simply read it in. So Python interacts with files on disk using the open and close commands. When we open a file on disk, we create what's called a file handle, which is a variable that allows us to access and manipulate files. We've included a file in the data folder called sample.txt. You can see that if in data wrangling you go to data, there's a sample.txt file here that has 3 lines of text in it. Hello, congratulations, you read in data from a file. So we'll go ahead and open that file, and we'll create this file handle F that connects to the open file. Then we'll read in the lines by reading from the file handle and assigning the output to data, and then we'll close the file handle. So we'll close the file. And we can see if we print out data, we see those 3 lines from the file that I showed you before. And F, this file handle, is this kind of complicated object that it's an I/O wrapper for input-output. It connects to a particular file. It has a mode, an encoding, all of these things. So as I mentioned, this F object is called a file handle, and it connects the interpreter to a file on disk. And the typical pattern we'll follow whenever we're interacting with files is we'll open them, we'll do any reading or writing, and then we'll close them. And since we pretty much always want to close the file when we're done with it, because we either want to not lock down that file from other programs, or because simply we can only have so many open file handles. We'll often open Python files using what's called a context handler. So we might say with, that creates this new context. This open file as F will read the contents of the file. And this has the effect of once the body of the context executes, Python will automatically close this file. Now in Python 2, it used to additionally say that this file handle was closed. In Python 3 it doesn't, so we can't see for sure that it's closed. But trust me, it is indeed. The proof is that I can no longer do f.read. I get a value error and it tells me IO operation on closed file. So f is indeed closed. And that happened automatically because we used this context handler. So by far, the most common pattern used when interacting with files is with open whatever file as some file handle. And then we interact with the file in the body of that context. So far, we've read in an entire file, but we can also read in individual lines. So for instance, we can read in just the first line by reading one line. And each time we add a read line expression, we read in one more line of that file. So it has the effect of reading in the line and bumping the cursor down to the next line. Then we can read the next line. We can also read all the lines in a file by using read lines. Note that the difference between using read lines and read is that read returns a string. Let's see here. If I just print out the type, we see that read returns a string, while read lines returns a list. And each element of the list is a single line. We can also similarly write data to files. Every time we've opened the file so far, we've had this little R after the file name. This R stands for read. So we call this, a flag or a mode. And we've been giving the read mode every time we've opened this file. In fact, we saw that when we printed out what this F object was. It said it was in the read mode. It's important to specify what mode you want to use to open a file. Usually we'll only be reading or writing from a file. And we don't want to necessarily, we don't want to mix those up. If we're reading and writing from a file, then our cursor might move around as we read or write, and it might not be in the position that we expect, leading to incorrect reads, reading parts of the file we didn't intend to read, or writing new information into a file that is in the wrong location. To open a file for writing, instead of giving an R flag, we give a W flag for write. So we're going to open a new file called mydata.txt, and we'll use the file handle to write lines to that file. When we read it back, we see that these actually did not write to separate lines. They wrote on the same line. If we look back at the read lines command we did earlier, we see that each line ends with this \n, which is what's called a new line character, as a string that's interpreted as bumping down to the next line. So if we wanted these on separate lines, we would need to do a new line character after the first line. And now these lines are on separate lines. Notice that if I run this cell many times, I always get the same output. This tells us that every time I write the file, I'm overwriting the old version. Opening with the write mode will overwrite a file if it already exists. If we want to add to what's already in the file, we need to open with the A flag, which stands for append. So I can add a new line to the file by first of all beginning a line with a new line character and writing to it in the append mode rather than the write mode. I still use f.write to write the data, but I'm appending to the file. Now we see our new line got added. And if I run this several times, I'll keep adding new lines to the file. Of course, anytime that we're writing data to disk, we need to be careful. We could overwrite or alter data that we don't mean to modify. This is why these flags are really important and really helpful. They control how much access we get to a file, or what kind of access we get to a file. If we try to do something to a file, which we're not allowed to do with a particular flag, then we're going to throw an exception. For instance, we can't open a file for reading if it doesn't already exist. So here, there's no such file or directory, data_fail.txt. I can't even open this file for reading, let alone read it, because the file simply doesn't exist. In order to read a file, it must already exist. That's not the case for opening a file for writing. Here, we'll encounter a different error because we can't read a file that's open for writing. Unsupported operation, not readable. However, notice there was no problem with opening a non-existent file for writing. When we open a file for writing, if the file doesn't already exist, it will be created. But if a file is open for writing, we're not allowed to read it. Similarly, we can't write to a file that's open for reading. There is an option for opening files in a mode where we can both read and write. If we add a plus after the flag, let me actually bring this into a new cell. If we add a plus after the flag, this code executes just fine. And if we open with R+, we can write to the file as well. But we should be careful about using these modes. Remember, if we open a file for reading and then write to it, when we start reading, our cursor will have moved. And in general, it's not usually necessary and can be very confusing to try and both read and write to a file in one pass. So, one question we might ask ourselves is, how can we find out what files are on disk so that we don't try and open files that don't exist? Or, if we're opening a file for writing, we're careful to avoid overwriting an existing file. That'll be the subject of the next video.